Hello, good afternoon, ladies and gentlemen, also here in the audience in Vienna and worldwide in front of your computer screen. Welcome to this autumn hearing session, and this is a very special one. It is the very first time that we broadcast live from the Vienna Hofburg, from the Austrian INT Society meeting here in the old Imperial Castle, and we have a live audience here in the room. And we have a distinguished panel here in the broadcast. But first, I want to introduce a little bit the hearing. The hearing was founded in the year 2007 and started its activity in 2008 for the comprehensive hearing education from the very best otology department worldwide. So the founding members were Vienna, Würzburg, Antwerp, and Warsaw. And in the meantime, the hearing is over 33 ENT departments worldwide, and we are very proud of that. We work together. We are a global network on all continents, Europe, also South America, Australia, and we work together very, very much. We try to be innovative, to do some publications together, to be comprehensive, to be educative, and also coactive. So we are not only surgeons, we are therapists, physicists, different other subspecialties, technicians, basic researchers, so all kind of people working for the hearing implant technology. Now for you at home on your laptop, please close all your programs and maybe please name yourself. You can identify yourself and you can also ask us questions. So I have here a small panel you can see, and here I can see directly your questions you ask us at home. Yeah, so it's a very nice meeting. I hope that you enjoy, and we have a distinguished group of guests all together. We have Professor Robert Blinsky from the University of Rostock. He has a lot of experience in vibrant sound bridge, and actually it's his fault that his couplers are all available. We have Piotr Skarczynski from Kajetani from the World Hearing Center, the biggest cochlear implant center worldwide. He will talk about the bone bridge today. We have Professor Timo Stöver, very important. Actually, it's an old partner clinic of Vienna. He's chairman in Frankfurt since the year 2009, and he has a long-lasting experience. And without him, the German cochlear implant world would be not the same. We have Professor Joachim Müller. He's the pioneer former times in Würzburg, now in Munich, and he introduced the bilateral cochlear implantation and the single-sided deafness. And last but not least, Professor Gunes Rajan, now in Lucerne, but also for the University of Western Australia in Perth, and he will talk about electric acoustic stimulation. This is an official network from the CPD certificates. You will have points for later on. And now we start with my own presentation. So let's see, I want to talk a little bit about the history of the cochlear implantations. So we should not forget the very first surgery in cochlear implantation was done in 1961 by Bill House, of course, in Los Angeles. But this, until at that time, were only single-channel cochlear implants. The very first multi-channel cochlear implant was done in Vienna by Professor Kurt Burian, and it was a year prior to the Graham Clark group in Australia. So a year earlier, we did already the very first multi-channel cochlear implant here in Vienna. And the very special thing is, it was a multi-channel implant with monopolar stimulation. This is very, very important because some other competitors at those time had bipolar stimulation with what found out to be inferior to monopolar stimulation is very important. And actually in the 70s, there was a very old implant. It was called Innerate with a pedestal like a Baha, actually a transcutaneous system where you had plugged in the audio processor outside the patient. But the very first multi-channel cochlear implant was done in Vienna at the time, and Ingeborg and Herwin Hochweier, he provided with the implant. You see here the original slide, and this was a very, very big step forward. Additionally, you see here in those days, the old the old transistor, and what you can see here, you see these 8 metal plugs. So these are condensators, and these are extremely important to provide eddy current. So this is extremely important in monopolar stimulation, and this is what we still need nowadays. So for cochlear implantation, this was very, very important, and on principle, all modern useful implants will have the same. Then we had, of course, the body-worn processors in the 1980s and very early 1990s. And some might have forgotten, we had already the very first behind-the-ear speech processor in the year 1989 here in Vienna, in those days still with the analog implant. And then we were the very first ones here introduced in Vienna in 1996 with the very first behind-the-ear speech processor, which was a very big step. If you look additionally to the implantable hearing aids, there were very, very many failures, and unfortunately, I was actively involved in most of these failures. So I did a lot of BAHAs. I did the TICA, the Total Implantable Cochlear Amplifier, with Professor Zenner in Tübingen. There was a device in Japan, the Rion device from Professor Yanni Gihara. There were different other devices, and all of them failed. So none of them, not a single one out of this, is still on the market. I remember the Retro X from Dr. Wiesenthal in the year 2004. We had the Soundtech implant, which was a copy actually from the Symphonics implant. We had the Envoys and Cora Medical. We had the Otologics device for more than 25 years research and about $1 billion invested with no outcome. We had already the Total Implantable, but unfortunately, all of them failed as well. The only one system which survived was the Vibrant Sound Bridge, acquired in March 2003 by Medel Company, and the Vibrant Sound Bridge with all the different couplers is the only one device which is still working, and later on also in the year 2011 and later 2012, the Bomb Bridge, which is still alive. You see here Jeffrey Ball and myself in the 2 years, 2006 and 2007, in our Vienna operation room. And this is where the time where we designed the Bone Bridge implant, but it lasted quite some time. Georg Sprinzel did then the first pediatric surgery in June 2011, and I could do the first pediatric surgery in March 2012, then in Vienna. This was just 3 months before the official release of the implant in our bone lab in Vienna with the first tests. And the Bone Bridge is actually the implant, Professor Skaczynski will report about it, which is still alive and is actually an outstanding outcome. In the latest years, of course, we have all the streaming functions with the audio processors. Very important, we have the Autoplan for the planning of the surgery. The Autoplan, the very first version, was introduced late 2015. In the meantime, we have all the modern cochlear implants, fast stimulation. The total cochlear implant will come very soon. We have the Hero, the robot. We did now altogether 65 surgeries in the research group together, 65 very successful surgeries. And we have also newly introduced in this year, 2023, the Flex 34 electrode. And I like this Flex 34 electrode very much, but I need to admit, it's not my invention. Professor Müller did it. He's here on the panel. It was Professor Müller's idea to have the Flex 34. Now some other presentations. I think I'm now at the end, and we will start now with our journey to the next. And our next journey is actually to Rostock.
Thank you. Hello, everybody here and on the internet. Vibrant Sound Bridge, a story of success. The story of success started with the genius invention of the floating mass transducer by Jeffrey Ball, who transfers electromechanical energy into the cochlea using the ossicular chain. Originally invented for a sensorineural hearing loss, the FMT was placed at the long incus process parallel to the stapes and then driving the cochlear fluids using the stapes. In 2006, Vittorio Coletti, for the first time, has driven the cochlear reverse by placing the FMT at the round window. And the multi-center study gave this approach a CE approval, and this was the breakthrough for all the patients with a combined hearing loss. Driving the oval window, there are several very special indications, and the coupler, as mentioned, are the one crucial part to get the FMT force standardized and reliable into the cochlea, especially in combined hearing loss. But the same is possible for sensory hearing loss and otosclerosis, where we combine the FMT together with stapes prosthesis or just using the Incus. So by now, we have 26 individual applications to drive the cochlea reverse or forward using the ossicular chain, the oval window or the round window, and the coupling elements. By this, the Vibrant Sound Bridge is an active middle ear implant which is indicated when a hearing aid is not helping and the cochlear implant is not yet indicated. And in these cases, the active middle ear implant Vibrant Sound Bridge would be the consideration of choice, because for almost every anatomical condition, there's a fitting solution with the FMT and makes it a very personalized treatment for the patient. And with the last slide, I would like to honor my teacher or our teacher, who already had in 2001 the idea to use the FMT driving the cochlear fluid. He's now late, and I thank him for his teaching, and I thank you for your Aufmerksamkeit, your attention, and of course my team, which is here. Thank you.
Yeah, Robert, thank you very much. Now it's time for questions. So the question is, when we started with the Vibrant Sound Bridge, it was purely for sensory neural hearing loss. And then later on, it came to mixed hearing loss. So the question to the panel or to Robert, who you ever want to answer, how do you see the Vibrant Sound Bridge right now in comparison to hearing aids? And how do you see its recent indication? What do you want to answer?
I think you go ahead.
Robert first. Okay, so in hearing aids, I think there is a very nice indication when we can use the Vibrant Sound Bridge, especially with the enlarging number of patients with some problem with external meatus and some mixed hearing loss, and also pure sensory hearing loss. So there is a lot of patients also in the water sports group. They like it, and instead of make surgery and resurgery of them, this is short information for the especially not experienced our listeners today to have that application.
So Robert, what is, for example, a sound bridge patient you like most for surgery? So what is the prototype for a sound bridge patient? Which is the best?
Well, of course, the most easiest surgery would be the patient with sensory or hearing loss and an Incus approach in the attic. So they're using the short process, Incus coupler. But these patients are not the most, the largest group of patients. I think there's more patients what have unsuccessful rehabilitation after conventional middle ear surgery and chronic middle ear disease, and those are the patients what benefit most, and because they cannot be sometimes rehabilitated with conventional hearing aid, and for them it's really a success.
So I want to repeat it again. So we have the possibilities, classic, the long process coupling. We have now the short process coupling. We have the round window coupling. We have the bell coupler, like in a partial prosthesis. We can have maybe a fenestration, or maybe we can have also an oval window coupling. So the question is, there was a big discussion, it's still, what is better? Is short process coupling better than long process coupling? Professor Müller, what do you believe?
Well, theoretically, long process should be better, but the work of Dr. Mlinsky showed that there is no major difference for clinical application. And you have heard from Professor Mlinsky that there are about 37 varieties of coupling the FMT to the occipital chain or to the inner ear. So this gives room for creative young surgeons to put brain input and decide about new applications. I want to mention two applications which had not been mentioned. First is the restoration of hearing for atresia cases, which has completely changed. We have learned from our teacher, Robert Minsky has shown that even in experienced hands, the results of ear canal reconstruction is limited. And this is completely changed. So we don't do any ear canal reconstruction anymore. We use the sound bridge for these patients. And also in cases of otosclerosis, the short process coupling is a nice way to overcome the sensory neural hearing loss. And yeah, I congratulate you for this idea. This is a great tool.
So in our series of patients, we have the impression in Vienna that the classic long process coupling is superior to the short process. But this certainly needs to be worked up by higher patient numbers, but this is just our impression. I have some more questions, but I will then ask later on after Piotr Skaczynski. Before we move on to the next topic, to the bone bridge, are there any questions here in the audience concerning sound bridge, whatever you want to ask? So at the moment, no more questions. So then we go on to our next journey.
Thank you very much for your attention, dear friends. I remember our first meeting with my poster in 2006 here in the Hofburg. And in that time, the vibrant was the topic, more or less. The bone conductive devices were not as much discussed as they are today. So as we heard about the vibrant presentation, the bone conduction and bone conductive device is for children, young children, and also for adolescents and adults, but there are two different indications. Microtia and atresia, you can use vibrant sound bridge. It depends on anatomical conditions, but we can see the huge increase of numbers for patients to have bone conductive solutions like bone bridge without need of external matose reconstruction. There is single-sided deafness. Now the topic is a little bit not as discussed as earlier, because if we can, we always offer for single-sided deafness cochlear implant. If we cannot, if there's ossified cochlea, if there is no chance to put the implant, then we can go for single-sided deafness, and huge increased number of patients. There are patients with after cholestatoma, after radical cavity, after many surgeries, when we are not successful and the patients, they demand more and more, we can offer them that solution I will show you later. And you can see how the device looks like. It looks like very nice. Remember in your practice that skin conditions are important, and if the patients with too high BMI is also not good patient, because the magnet also need to be on place. So it looks very nice. There are different placement. During last meeting in OSEO in Denver, majority of the centers started to do bone bridge in general with contact with the dura on with or more the middle fossa approach than the mastoid, typical. You can see that the surgical procedure is quite important. Very important issue is that transmission is going through the screws. So the screws need to be in the robust bone. The bone should be in good condition. You need to make the hole in the place. And for me, very important is the skin to avoid the complication. Results are very good. You can see on the slide from without stimulation, with stimulation in different presentation. But what I would like to underline, when there was the launch of the 602 bone bridge, till that moment, we have only 11 pediatric patients. Now the number is totally different because the device is smaller, it's only 4.5 millimeter in the bone. So that application increased, but the number of patients, we have a lot of them in the waiting list. There are patients after many surgeries like canal wall up, canal wall down, then we make reconstruction. You can see this is biactive glass. So you need to, for that procedure, you need to must have dry ear. After dry ear, you can make reconstruction. You could make it in the same surgery, but I'm not big fan of that because there could be later not as good healing. It looks on the CT scan, and you can see that results from audiological point of view and from surgical point of view are very important. Very important issue is what means the bone conduction. The size is from 0 to 45 dB, but better bone conduction you have better results. So, we can see the average bone conduction is 24, 27 dB. And also that results on different, sites are very good. You can read it in the publication. But what is for us very important? This is a very effective solution. You need to have good cooperation with audiologists. They need to try that bone conductive solution like adhere or something that they have to avoid. There's some disturbance or some problems with the bone conduction. Sometimes people, they don't like it. You have something what it's not intact with the ear. For example, patients after surgeries, which were 20, 30 years ago, they have wet ear, they have some problems. We could treat them. And as Professor Baumgartner presented, radiological image is also important because we need to plan where to put the device to be as optimal as possible. Thank you very much for your attention.
Piotr, thank you very much. And I wanted that both lectures are finished because now I can ask my most favorite question, also maybe for the audience. Piotr, what do you like more, the bone bridge or the sound bridge?
I like personally bone bridge much more, but from the patient's outcomes, if I have not enough good hearing, like for example 50 dB, the vibrant results on the round window are the best. So this is really good. But for us, it doesn't matter if it's vibrant or bone bridge. Bone bridge is a little bit shorter. But for unexperienced surgeon who would like to come to the implant world, I think it's better to start from bone conductive device. And when you will be more experienced, then you go for vibrant because it gives that. If you ask me about a long process or short process, my impression also is that long process is a little bit better, but the surgery is a little bit more difficult. But after Professor Miński, I also agree that we need to increase number of patients under observation.
Mm-hmm. And so do you have now more pediatric, also to all in the panel, do you have now more pediatric or more adult bone bridge patients? So we have, in general, we have more adult patients, but all our pediatric cases are malformation cases. So we have about 20, 25 pediatric cases in this series since 2012, and all of them are atresia cases. So how it's in your departments? Yeah, Timo?
I think it's rather the same. I think the good thing about the bone bridge is that, especially in children, you can take a good shot, and if it works, that's a good solution. You don't destroy anything. And you still have the possibility to implant the vibrant sound bridge at a later point without affecting this chance. So it's a working good solution for the moment. Maybe it's even the best, but still there's another option for later. So you don't have to necessarily take the risk because it's small anatomy and maybe a small child, difficult anesthesia. So I think it's a win-win situation at that point.
Yes, very good comment. We come back to this later. We need to say the bone bridge, we have now since 2019, the 602 bone bridge, so 602. It has a thickness of 4 millimeters. And if you use the 1 millimeter lift, then the thickness is only 3 millimeters. And that means the bone bridge is constructed that it does not harm the skull or the skin at all. This is very important because there are some implants out in the market who are already preformed for the future complication. And this is what we definitely avoid with the bone bridge. But there's just one point. There is always the rumor, I'm not sure if it's scientifically true. So some people, even well-known professors, claim that the sound bridge is in outcome superior to the bone bridge. And if I look to our patient data, I really doubt that. Quite in contrary, I need to say, we had sound bridge patients in Treacher-Collins syndrome or in other syndromic patients where we had round window and also fenestration surgeries. And after 10, 12 years, we removed the old sound bridge and changed to bone bridge. And we could not see any difference, quite in the contrary. So the outcome for those patients, although they're all atresia patients, but their outcome with the bone bridge was even better than with a round window vibrant sound bridge. So what is the experience of the panel, whoever wanted to ask?
Maybe I can
After
give a comment on that. I think you still have to consider the limitation of a bone conduction device just because of the mechanics that's there, right? There's an ideal resonance frequency where a bone conduction device works really well. And that probably also explains why in a purely conductive hearing loss, both are really good, you know? But the difference of the active middle ear implant is it's the direct stimulation of the inner ear via the ossicles or directly through the round window, which means, you know, the sound energy transfer is much more efficient. And obviously there's no acoustic loading of the other ear, which you have in a bone conduction device, because, you know, the waves get transmitted through the skull. So I think just from a mechanical point of view, you know, you have to consider that. And with the, in a purely conductive hearing loss, as I said, it works well, and that's what confirms your findings. But the harder, the more the inner ear component gets, I think the more efficient the sound bridge gets, just because of the mechanics.
Robert?
Crucial definitely is the coupling of the FMT to the cochlea. So it is very advisable to use intraoperative monitoring, especially BERA, stimulating the device during the surgery to get optimal coupling. And using programmed audio processors for this testing, you can get up to 5 dB or 0 of the threshold of the individual patient. And then this makes the surgery now much more safe than in the beginning, where we had, of course, due lacking this testing methods, some failures.
Thank you very much. This is all I wanted to hear. So we had no rehearsal beforehand. We just came together here 5 minutes ago, and we can say, if there is a pure conductive problem, as Professor Rajan said, then obviously there is not much difference in between sound bridge and bone bridge. But if there is a sensory neural component, so an inner ear problem additionally, or a pure inner ear problem, then definitely the sound bridge has better properties. And additionally to all of this, it is dependent on the coupling and of the efficiency of the coupling. Yes, thank you very much. I have now a question. I hope I read it correct. Yeah. Is it, listen, gentlemen, is it safe to use the bone bridge in post-radiation therapy? Yeah, so that's the question. Yeah, so who want to answer?
Of course, it's possible,
Yes,
but
absolutely.
for me, for bone bridge, skin is extremely important. So I need to have the skin which is good. So if the skin is radiated or there is dry or there is some problem, we need to be careful on the placement. Sometimes you need to go on somewhere different, superior or posterior. But absolutely, it's possible to do it after radiation, to do the surgery.
Yes.
Can I just add to that? Once the skin, the other is the bone quality. And with the old radiation therapy regimens, they were really hard on the bone, and you could have osteoradionecrosis. So really you need to have a look at the bone quality, especially with the bone bridge. But I think in nowadays regimens in radiotherapy, the likelihood of osteoradionecrosis is low, also in the temporal bone.
What can be a problem? Which recently had a patient, she had a parotis carcinoma and had radiation beforehand. And then the problem was with the bone bridge that after 2 or even 3 years of the bone bridge in the pre-radiated skin, we had a difficult skin issue on that. Robert?
Another important issue, if you consider a patient who needed radiation, he probably has a temporal bone disease, what needs monitoring. And also this needs to be considered because you get a masking of the place of disease with the bone bridge. So if you think of glomus patients, what maybe sometimes treated signal-sided deafness, so then you should be aware that there's an issue in monitoring the disease.
What we found out in our patients, we have now altogether over 300, 350 patients, bone bridge, sound bridge together. The bone bridge patients are usually the desperate ones. In mean, a bone bridge patient, until he receives his bone bridge, has 5 or 6 unsuccessful ear surgeries beforehand. So the bone bridge is then his 6th surgery, and this fortunately went well. Our record patient, I don't know if a colleague from Brno here in the room, was in Czech Republic. We had 27 surgeries prior we did the bone bridge, and these are different candidates than sound bridge. Is there any question? Or yeah, Professor Stefan, please.
What's your experience with a bone bridge in single-sided deafness?
Ah, very good question. Who want to answer?
If I can, I put CI always. This is, I think, the best answer. If really there is no chance, and for example, 2 months ago, the facial nerve was in such position that we didn't want to risk together with patient. Second, there is the issue when the cochlea is really ossified and there is no chance. And also when in radiological, there is no answer on ABR and MRI shows that there is some problem with the nerves or absence, then we go for one. So that number decreased significantly.
Let me interrupt now, because this leads us to the next journey to Professor Müller, because maybe we can discuss this a little bit later.
I will summarize the experience of bilateral cochlear implantation and single-sided deafness in 4 minutes. We have seen a lot of developments over the last 40 years. Many details have been improved, but in terms of patients' outcome in speech understanding, bilateral implant had the biggest impact on the performance of patients. Well, that's how it began, but that was too quick. That is Mr. Wickman, the first bilateral implanted subject. And it easily shows what we achieve with binaural cochlear implants. We achieve the fundamental aspects of binaural hearing with directional hearing and better speech understanding in noise. As you see, the young assistant doctor, it was done quite a years ago, but it worked even shortly after first fitting. Well, maybe we have been lucky at that time, 1996, when we implanted this patient bilaterally. If we look back, we had the Combi 40 available with a high-rate CIS strategy. And looking at the speech understanding results of that time with 60% monosyllabic words after 1 year, this is, even if we look back, an outstanding performance that has not been performed with other devices at that time in that area. And it showed the high quality of the implant that we used. However, the processors were behind, no behind-the-ear processors, but body-worn processors, and the parents become very creative and created shirts for the children to wear those processors under the arms. Well, we were blamed to be unethical while we serve 1 kid with 2 implants. That was a nice and sometimes aggressive discussion, but the results that we could show with a better performance with the left or the right ear compared to the binaural use was confirmed by many, many papers. And one of Bus in North Carolina is a nice one, because they compared the binaural performance either to the left ear and to the right ear. And thus, even compared to both ears, to the better ear and the worse ear, we showed the performance. Bilateral CI users benefit from the head shadow effect, the squelch effect, and summation effects like normal hearing people. In terms of binaural hearing, we are able to reach a minimal audible angle as presented close to normal hearing persons. The localization error decreased with bilateral CE, and also with the medial cochlear implant, spatial hearing was possible because also these patients with the CIS strategy had access to interval time and level differences through the clinical speech processors as well as through research speech processors. As a logical consequence, 2005, the first single-sided subject was implanted with the pulsar device by Dr. Jakob in Koblenz. And in our group of patients with single-sided deafness, we achieve a mean improvement in the OLSA test from 2.7 dB. But standard deviation shows that we have quite a heterogeneous group that we are serving. But the results were convincing, and so we served also children with that. However, when it comes to children with single-sided deafness, it is important to see the auditory nerve going into the modiolus. 60% of the children have no nerve in the last 2 millimeters in the modiolus. Well, what we also have learned from single-sided deaf subjects, we need long electrodes to perceive low frequency tones. This is important for directional hearing because substantial part comes from low frequency hearing. And so we are happy to see the Flex 34 on the market, which is my thanks to Medel who bought this. Thanks also to Andrea Schreier, who is in the room. He will take care of the data collection of this new device. In terms of children, we have learned that early implantation is beneficial. We have a better speech understanding, a quicker overall development when we implant before the first age of life. So challenge is CI both ears before age 12 months, before the second phase of bubbling comes. And also these children develop directional hearing over time, which is not possible with only one implant. Surgical aspects is a nice room for discussions, whether we should do it simultaneous or sequential. Both has advantages, and I think it's not a dogma how to serve this. Well, in 1996, our promise was adults and children do better with bilateral implants. We see better speech understanding, I have shown you, but modern people look in quality of life. However, quality of life is a different term. Everybody means or thinks that he knows what it is, but nobody needs how to measure. Our psychologists did some questionnaires. I go not into detail with that, and measured the quality of life of the early implanted children. And for me as a surgeon, the most impressive result was that the satisfaction with life scale showed exact the same value or self-assessment in bilaterally implanted kids compared to the age pair normal hearing group. So bilaterally implanted kids do not feel any handicaps compared to their pairs. And this was also seen at the Lasker Award ceremony when Max, the first implanted child, who is now in research and development for cochlear implants, chatted in English with Bill Gates, and he was not able to see that he was an implant user. But quality of life is not data, it's also life. And that's what we experienced in Japan at the Sound Sensation Festival. When implantees brought jazz to the podium, we enjoyed that very much. But we enjoyed much more the afterwork party in a little jazz club, Noisy Duck in Yamagata. Whenever you have a chance to go to Japan, go there. That was really showing how life is increased. Well, at the end, we have to thank for support and confidence, especially to our teacher, Jan Helms. Robert Minsky has mentioned that, but also Eckhard Schulz, head from Medel Germany, had a major impact in bilateral implants in terms of reimbursement and discussions with insurance companies. And he brought a lot of impact that made the reimbursement possible for our patients. With that, and the last slide, I want to introduce an upcoming meeting with Professor Baumgartner. The idea was developed a week ago, and we please aware of the Niederkaltner Kirchner HNO-Tag. Thank you.
Professor Müller, thank you very much. Now I think it's easier to discuss the question in single-sided deafness. But let me tell something else. When we did the very first bilateral surgeries in 1996 in Vienna, we were just about the same time as in those days Würzburg, but unfortunately we were too slow to publish that. And so all the honor went over to Würzburg. But the point was, what we found, we had in those days the Combi 40 Plus implant. And what is completely forgotten, to have bilateral effects, you need physical and pure physical properties. Because Bill House already did bilateral cochlear implants in 1971. But why nobody has talked about this? So the point is to have all the bilateral effects, to have a head shadow effect, to have a squelch effect, to have a summation effect, you need following properties, which were only present in those days with the Combi 40 Plus implant. You need a long electrode with a deep insertion. With a shallow insertion of 10 millimeters or even 20 millimeters, you will not achieve bilateral hearing. You have two hearing ears, but they will not work together. You need monopolar stimulation. This is mandatory. In bipolar stimulation, as some competitors had it in those days, you will not see a bilateral effect. And you need a fast stimulation. So you need a stimulation in each channel from about 3,500 pulses per second with new information onwards. So we had in the Combi 40 Plus in those days over 18,180 pulses per second, which none of the competitors had achieved at all. So of course the others could not see any bilateral effect. And it was for us extremely difficult to publish this in the late 1990s because only surgeons with a full deep insertion, with a long electrode and a fast stimulation and a monopolar implant could show these effects. The others could not and still cannot do it today. So this is why in the meantime, all implants from all manufacturers work on those principles, which the implants we use worked since the beginning of cochlear implantation. So, but beside this, Joachim, what will you answer now, Professor Stefan, for the single-sided deafness? Will you give him a bone bridge or will you give him a cochlear implant?
Well, the first question is how long would he be deaf on this side? And what do we have to expect from a cochlear implant? And then I have to ask him if you want to go a major surgery or a smaller surgery. And especially in elder people, some are happy with a short bone bridge surgery. And for the bone bridge, we can simulate with a bone conduction device prior to surgery what the patient has to expect. And about 5% of the patients, especially elder patients, feel that this is for their communication situation enough, and they are happy with the bone bridge. But the majority would go for a cochlear implant. That was the preferred choice, especially if it's a short-term deafness and the implantation is short after sudden hearing loss or whatever. I mean, also for the surgeons, this is a nice device. If we think about surgery on the last hearing ear, if something goes wrong in staple surgery, then we should be aware that we have ossification within a few weeks, perhaps, and then we have another tool where these things that can happen can be restored for the patient.
Any other opinion on the panel concerning single-sided deafness? Okay. I need to tell, we had our learnings. So there are patients who do maybe better with a bone bridge, especially those who are maybe a longer time deaf or who are not, let's say, so motivated for therapy or learning, or you do not know exactly the etiology. We also learned that in quite a number of single-sided deaf patients, they simply do not have a hearing nerve on this deaf ear. So you cannot do a cochlear implant. So a cochlear implant is really the restoration of the organ. So the bone bridge is the second best, but nevertheless, there are a high number of patients we are profiting this. So I think at the moment, I want to leave it as this. Maybe we have later on some time to go more into detail. But now I want to go with the journey to the University Clinic of Frankfurt to Professor Timo Stöber.
Thank you, Wolfgang. So the move to the new clinic will be in January next year, only a time delay of 10 years, about double the money, but hopefully we'll start. It's the truth. So now there will be a totally boring topic, which will be setting standards or talking about quality control. Actually, it's not, because it's something that has been discussed in Germany quite intensive for many reasons. In the end, I will show what consequences has, what we even did not think about when we started. So what is quality standards in cochlear implant therapy? Basically, it's like everything in quality control. You do what you promise to do. That's quite simple. The thing is, and the problem is that maybe it's not really defined what has been promised. So first of all, we have to define what should be done, and then we can check if this has really been done, and maybe define what is the best way to do what we think should be done. So after, I would say, about 6 years of discussion and quite intensive fights with different specialty units, we had an agreement in Germany within the German ENT Society, the Audiological Society, and the Society of Phoniatrics and Pediology that there should be a quality control being established. And there are basically 3 columns where this is being founded on. First of all, we had to define a clinical practice guideline, a Leitlinie in Germany. The second thing was we had to translate it into a practical guide how to do this in daily life, which would be the White Book or Weißbuch. The third thing is that we thought it would be not only a nice thing, but a necessary thing to do to establish a register, because only register data and performance data would enable in the future to really create a structure and a quality control which is founded on success or not success, but not only on knowledge or ideas of specialists. And we had the idea that if a hospital is going to follow all these rules, the clinical practice guideline, the White Book, and is participating in the register, then they should show this to the outside, to patients, but also to other hospitals, maybe to the health cost coverage units, Krankenkassen, in order to perform a certification process. So you would receive a certificate stating that you follow all these rules. This process started about 5 years ago. And especially in 2021, we had quite some achievements. So what's the content of the guideline, the clinical practice guideline, and also the White Book? Basically, it's to really cover the whole process, not only talk about indication and surgery, but also how to fit a patient, so which we would call the basic therapy, Basistherapie, also the follow-up therapy, which would be everything but which would follow the initial fitting of the processor. And finally, and this is even, or is very important, the aftercare. So lifelong aftercare, taking care of the patient for as long as he's going to use the implant. So we are not going only to talk about when to indicate an implant and how to perform it, but also how to lifelong take care of the patient, and therefore also to monitor the results and maybe the negative results. The other thing is we strictly orientated ourselves to quality aspects. So we defined a process, what should be done. Then the structure should be quality defined, meaning who is going to be able to do something? What kind of qualification does the person need in order to not do the surgery? That's clear. But to fit a patient, to adjust the audio processor, to perform the aftercare. So it's a question of qualification, of structure in terms of rooms, of equipment, and also everything that is required to perform this process. And finally, also it's the result. So the result control, what kind of positive and negative results we want to expect and not want to expect or want to exclude. That's all been covered by the clinical practice guideline. So what's the status right now? I have to just turn around just a little bit. So we established the clinical practice guideline in the White Book in 2020 and 21. Since 2021, we established the registry. So 70 clinics in Germany participate in the registry. By the end of last year, already 2,500 implants were registered. I don't know the actual numbers, but it's to estimate that the number will be around 4,000 or 5,000 this year. So it can be estimated that in a couple of years, maybe 3 or 5 years, we'll have about 10,000 patients in this register. So it's a large pool of data that would provide data on quality control and outcome. Right now, about 50 clinics conducted the certification process in Germany. So they follow the clinical practice guideline, participate in the register, and also follow the White Book guideline. And of course, the register is the basis for the future work of next development of the clinical practice guideline. So only data will be or should be the basis for what we do to the patients. Well, there's a lot of secondary aspects we didn't really anticipate. Right now in Germany, there's a big discussion on the Krankenhausreform, so restructuring the whole area of hospital practice, medical practice. And one of the parameters that will be used to differentiate ENT clinics is actually cochlear implant. And by using the certification system and looking for clinics that are certified, health insurance and the health ministry will distinguish between clinics if they are certified or not. And they will allow or forbid clinics to perform cochlear implant or not. This is something we didn't anticipate, but it's something that is, I guess, an outcome of our work. Finally, the question is, what's the situation in the world or even in Europe in terms of clinical practice guidelines and registers? And that's something we tried to evaluate recently. Actually, for clinical practice guidelines, there's a lot of work that has been done in different countries. So all the gray countries on the what's that left picture side, these are countries that do have a clinical practice guideline. Of course, there's huge differences. Sometimes it's only a page, sometimes it's 100 pages, but at least there's some foundation on what you think should be the basis for a process for cochlear implant treatment. On the right side, you see the countries being depicted in gray that do have a register. Who invented it? So wer hat's erfunden? Swiss. The Swiss people invented the cochlear implant registry. I think they were the first ones, still being in practice about 20 years. We should in Germany also be gray right now, but it's not a lot of countries. And I think there's a demand for a European-wide, if not a worldwide, registry for cochlear implant in order to found basis and found quality control for the best of the patients. Thank you very much.
Thanks,
Yeah, Timo, thank you very much for this important work. In Austria, we are 11 hospitals doing cochlear implants. And at the moment, I think it's quite impossible. I cannot imagine that all these 11, there are more than 11 surgeons. So let's say 20 surgeons that they would sit together. How did you manage, or which data are seen by whom? Let's say like this. I think this is the most crucial point, because actually in Austria, we don't even know exactly how many implants the other department is really doing.
This was difficult, but finally there was an agreement that we have to do it because it's better we do it because not the health insurance should tell us who is going to do cochlear implants. We should define from the ENT Society what is control and what should be done, and then everyone should follow the rules, but not the health insurance to tell us what the rules are. The thing is that there's also applications coming from other countries than Germany right now to be certified. That's interesting.
Yes.
Also from Austria,
yes,
by the way.
Absolutely.
The register thing. There is one annual report that is being given to the German ENT Society, being totally blinded. We don't know who is providing data. We only see the average data. each clinic is getting an annual report, seeing benchmark data, knowing this is the number of implants I did, and there's a number of clinics that did less and a number of clinics that do more, but you don't know which are the clinics. You only know this is your column or your plot, but it's anonymous. You don't know who the others are.
I remember there are about 120 clinics doing cochlear implantation in Germany, and you have now 70 registered. What happens to the other 50?
We don't know. So they decided either not to go for the certification process because they don't fulfill the rules, or they are not ready, or they don't want to. But 50 clinics follow the rules. Possibly 50 to 70 don't.
Mm-hmm. Gunesh, Professor Rajan, in Swiss, they started quite some years ago. I think it's maybe even 10 years. What is the experience in Switzerland?
I think it started over 20 years ago. So it's been, it's one of the pioneering cochlear implant database. I think what we, I think what we have learned is that any registry is only as good as the quality of the data that's been put into it. And I think that's been a major challenge also because standards have changed over time. Suddenly diagnostic tests have come in that weren't there 20 years ago. So I think it's really important that it's a group that looks after it, a steering board or something like that, that oversees the registry activity and also updates the ongoing activity that, because that's a representation of your society, of your work against the government, etc., third parties, which will be very important. Yeah.
And who is paying for that in Germany or in Switzerland?
In Germany, we are doing that by ourselves. So we have to pay for the certification and we have to pay for participation in the registry. The benefit is that you get an annual report. This is an automated quality report. And this is, I think, a fair deal. Mm-hmm. You provide data and you get them processed back as an annual report.
In Switzerland, it's similar. The maintenance of the registries by the societies, by the CI centers together, and there are only 6 in Switzerland, that's been set by the federal government. So there's no certification process because it's already been set. Who can do cochlear implants by the government? Yeah.
Right. Okay, now we do it later. I just want to go forward because we have a very important topic, because I wanted to have this topic in between the clinical talks. I didn't want to have this registry at the end, because it's not just an appendix, it's very important. And so now we have a very cool topic introduced in 1999 by Professor Christopher Milberg. He retired in the year. Actually, he introduced it in the year when he retired, and he did the very first surgery together in May 1999. Jan Kiefer and Christoph Ilbeck, the very first electric acoustic stimulation, cochlear implantation in residual hearing, and Professor Rajan will talk about this topic.
Thank you for the invitation. It's really exciting to be part of this panel. I'm very well aware, I learned that from one of my teachers, that 20% of what I say is perceived by 20% of the audience, and it will be forgotten in 20 minutes after my talk, right? So I'm very well aware of that. So I'll talk about the electric acoustic stimulation, cochlear implantation in residual hearing. And let's see whether this works. Not at the moment. There you go. So we've gone through a progression of cochlear implantation. Initially, we used to implant deaf patients, totally deaf patients. And then, as Professor Baumgartner said, 1999, von Ilberg and Kiefer and Leonhard, introduced the possibility that you can actually implant and preserve the hearing. And now we've moved on from that. We realized, we're not only, implanting, into the cochlea. By doing that, we're also violating the inner ear, for which, the vestibular system is also an important part. So now the concept of hearing preservation has evolved to the concept of structure preservation, preserving the inner ear during cochlear implantation. Why preserve the inner ear? Why electric acoustic stimulation? I think now we've reached a level of knowledge and awareness, hopefully, that we have come to realize that there's so many benefits for hearing, different dimensions of hearing, speech and noise, temporal and spatial perception, language perception, and music. And the other thing we have to keep in mind, as new treatments are coming up, regenerative treatments, that we want to keep that potential in the inner ear so that these patients, maybe in 10 years, 20 years, can benefit from regenerative treatment. So how do we preserve the inner ear during and after cochlear implantation? And this is the only slide you have to take home with, really, is that there's this concept of 2 hits to the inner ear in cochlear implantation. One's trauma during CI surgery, and the second hit is all the processes that get kicked off through the implantation in the days, months, to come after implantation. Basically, how can we tackle, as surgeons, how can we tackle the first hit? We have to understand the insertion mechanics. And there, the important thing is you have to keep in mind, you have to know that the inner ear doesn't like pressure changes, especially quick pressure changes. So how do you avoid? You have to think of that when you open the round window, when you insert the electrode, and even after you've inserted the electrode. So keep that in mind. How do we open the round window membrane? There's quite a lot of nice studies now showing that you can attenuate the pressure changes through opening the round window. For example, underwater, you make a big opening into the round window membrane so that the pressure can equalize readily. How do you insert the array? You do it very slowly, right? As slow as you can. The slower, the better. If we were able to do a 30-minute insertion, that would be awesome. But I think none of us has the patience to do that, or the skills. The other thing I want to point out, the design of the array has also a big impact on when, coming to damaging the inner ear. As you can see on the top left hand, you have the effect on the inner ear pressure with the perimodal array. And in the other 3 scenarios, you can see the effect on the lateral wall array have on pressures. And I think it's pretty obvious which one induces less trauma. The second hit, keep that in mind, that's all the inflammatory processes that get kicked off after implantation. How can we fight that? We can use pharmacologic in-ear protection. We can use hair cell, protect the hair cells and the neurons. And how can we do that? The easiest way we have nowadays still is steroids. It protects the hair cells, and then it also protects the spiral ganglion cells. And the take-home message from my point of view for today is, in order to provide electric acoustic stimulation, you have to preserve the inner ear. Combining the residual hearing with the electric stimulated hearing through the implant gives you multiple benefits in various dimensions of hearing. How do we do that? We keep in mind there's these 2 hits we induce as surgeons to the inner ear. First, while we put it in the implant, and then second, all those processes we trigger, in the inner ear after implantation. So if you keep, and I would acknowledge the whole team over the years has done this work. So if you go back, if this is the 20% you keep in 20 minutes, and 20% of you in the audience do that, I'm really happy about that. Thank you very much.
Thank you very much. And now the crucial question. We have 2023, not 1999. To how much residual hearing you go doing a cochlear implant? So what's your highest residual hearing, so the most residual hearing you have left, and you still decide for doing an implant? Okay, Timo, yes.
In Germany, we don't look for the pure tone audiogram, but for the speech understanding. So best aided 65 dB, we would ask for less than 60% monosyllable understanding. Then we see cochlear implant indication.
Very. Professor Müller wanted to ask.
Well, we would consider EAS with a use of an acoustic component according to the 5500 rule that was given a few years ago by Timo Stöver. And I think this is a good orientation also for patient counseling, whether he wants to go for acoustic electric stimulation or electric stimulation alone. And we are in a dilemma because patients with deep insertion do better with shorter insertion, but acoustic component in addition to electric stimulation gives also additional benefit. So this is the key question where I don't have a conclusive answer, but 5500 gives a good rule for the discussion with the patient.
Just recently in the US, finally, decades after we did the surgery, the electric acoustic stimulation surgery is FDA approved in the US recently in this year in 2023. So you shouldn't forget we started in 1999. And they changed for the United States in English language also the parameter. It's now 65% speech understanding in quiet for US. We should not mix up because that's about the same what we have in 50% of German language. Yeah? So the German language, it's much less redundant than English. So in English you need a higher score. But for EAs, how do you see the future? Is it the same? So I see personally a difference in a pediatric population or an elderly patient. So the question is, who is an elderly patient? I'm 56, so I don't feel elderly at the moment. But who is elderly? So who want to answer?
Yeah, maybe just to carry on the discussion, I think it's really important to know something about the cause of the hearing loss in these patients, and I think there the genetics will make a big impact. I think on the outcomes and also how to counsel the patients. Obviously, partial deafness can have so many causes, and it's really important to dissect that out. And get the information in the patient sitting in front of you.
Piotr?
In terms of when we decide for the partial deafness, it's first speech understanding, but we very much look for the speech understanding in noise, because quite often in quiet hearing could be quite good, but in noise speech understanding could be bad. How is the progressiveness of the hearing loss? So if we see that there is progressiveness, our patients are even up to, this is electronatural stimulation, up to 2000 good hearing, and there is no hearing in high. It's only 12 cases now material, so it's not good, but there was quite fast progressiveness. So we decided for them to make 20 millimeters insertion. In children, results are better, but the cause of that partial deafness is really important. So, for example, in Usher syndrome, faster we make implantation, results will be better, and how to adjust the length of the electrode for the hearing, for the pure tone audiometry, and to speech understanding. And I think in recent years and in future, as there was the question, I think we'll risk a little bit more. There is wonderful presentation from Agraval from Canada, how presents how is the apical part of the cochlea, how it works, how it influences. So always we go as deep as possible, what was not as obvious many years back ago.
Thank you. So especially in the US, we had the very first hearing preservation workshop in October 2002 in Indianapolis. And in those days, Tom van de Water, in those days, that was in his time, before even Miami, he was in New York at the time, we analyzed triamcinolone, we analyzed dexamethasone on a genetic base. How does it work in cells? How it does promote messenger RNA and so on. And we happily asked for any drug we could use additionally in electroacoustic stimulation. And now 21 years later, we're actually at the same stage. So we have not even invented at this particular moment a real drug for clinical use. Maybe I see Christoph Arnold here. Maybe some of his drugs from your lab, what you presented this morning, they might help in the future. Also Hinrich Stecker with Novartis. I would say that they failed. I'm very happy because at least a third of those patients really responded extremely well on the viral vector concerning for the inner hair cells. So a third of those patients really recovered. 2/3 did not recover. Unfortunately, these 2/3 were reason enough for Novartis to step out. But nevertheless, it's good to see that at least 1/3 of patients did respond on a pure genetic therapy. And now we will see, of course, in the otophaline or in other studies, which will start very soon, maybe there are some remnants or there is some trash for us we can use in electroacoustic stimulation. So, but now before we come to an end, are there any questions, remark, wishes from the audience, from you, asking us, the panel, and anything you would like to tell us? Not really. Okay. Yeah. Oh, Professor Müller want to ask a question. That's very dangerous. Okay.
Well, I like the concept that Gunesh has shown with the first hit and the second hit. But well, thinking about staple surgery, what time frame would you expect for the second hit to come, Gunesh?
I think it'll be weeks to months. I think immediate, quick, short-term changes are more due to the results of the insertion mechanics doing something to the inner ear. But these processes we know last for months, and because we are introducing a foreign body into the inner ear, which induces invariably an inflammatory response, and that is weeks to months after that, and that's where these drug-eluting electrodes will probably have a role to play.
So we should not forget, not so long ago, I mean, in the 80s, in the 70s, Bill House, Burian, these first surgeons, the pioneers, they were very much aware going into the cochlea. Bill House only introduced the electrode 6-8 millimeters. Even Burian, they were at the beginning of the second turn, maybe 20 millimeters. And actually everything started then with Wolfgang Stöttner, with Helms, with Joachim Müller, with myself for the deep insertion, actually in the mid of the 1990s. So, but I think now we nearly close. I want to thank you, but I have some slides. I hope they will come for the future. I hope I can't see anything. Yes. So please, for the audience, I've seen a lot of people. I can't number them, but it's a 3-digit number, a high 3-digit number on the computer. Thank you very much for listening us from Vienna. Please have a look to our Hearing.com homepage. It's only updated nearly weekly, at least monthly, and we have even more events to come. We have the hearing boost for the credit points, for the accreditation, for the accredited activity. It will take some time. And we have in 2 months at the Asia Pacific meeting in Seoul, I'm very happy, we will have another hearing roundtable, another very special topic. And also at the JICA for the Latin America, we will have another hearing roundtable. It might be great if you join us. Thank you here for the audience. And we have now coffee break. And thank you to all of you, to Professor Rajan, Professor Stöver, Professor Skasinski, Professor Mlinsky, last but not least, Professor Müller. Thank you very much to all of you. And for me, it was a pleasure to moderate, and stay healthy until next time. Bye-bye.